I think it was one of our panelists, I think it was James, he said we got some questions about retrofitting heat pumps versus new construction. I think his comment was, and the rest of the panel kind of agreed, new construction's easy, retrofits are the big league. And as a consulting engineer, so my name's Brad White, on the board with Automated Buildings, but I'm, in my day job, a consulting engineer that does primarily retrofits in commercial buildings. So I couldn't agree more. I mean, I love retrofit work, but it's challenging, and it's hard to make work well. And that's what we're here to talk about today, because I feel like a lot of what we end up talking about is the latest and greatest technology, but it tends to skew more towards the new construction side of things. So we wanted to have this session to really focus on the retrofit aspect, talk about all the challenges and the heartbreak and the success that we can have in retrofitting buildings. So we've got a great panel here for you today. They all have a lot of experience with retrofits. So I'm going to stop talking, and I'm going to get them to talk, introduce themselves, talk for a couple minutes about their perspective on how to make retrofits successful, and then we're going to have a little conversation. I would encourage all of you to start thinking about questions. As soon as they're done, you're welcome to start jumping in with questions. And I hope, we got a bit of a smaller group later in the day here, so I'm hoping we can have a good discussion, some good dialogue. So without further ado, Joe, why don't you take it away? Oh, is it working? You have to hold it kind of close.
Hello?
Hello.
Hello?
All right, that one's working.
Hello.
Hello. I'm Joe Brown. I work for KingSett Capital. We're an asset management company. Well, we're a private equity company, but I'm on the asset management team. We've got about 20 billion of assets in Canada, across Canada, major cities primarily, everything office, industrial, retail, some hotels, and what I missed? Residential as well. I'm in charge of building tech and decarbonization, so I've gotten involved in a lot of large-scale decarb projects across my portfolio. Everything from a $65 million heat pump retrofit at a 95-year-old hotel in downtown Toronto to a $3 million retrofit of an office building in Toronto, and I worked on one with Brad out in Vancouver that we're getting close to finishing it this year, where it's probably in the realm of like a $7 million retrofit of an existing office building. Yeah, looking forward to talking through some of the challenges that I've had on those, and they're definitely challenging. I'm involved with some of our new construction as well. The difference between those and the retrofits is vast. You start out with a new construction project, you can fix all the problems on paper. It's just a matter of changing people's ideas. When you go into an existing building, you don't know what you're getting into in a lot of cases. If you've got a nice clean building with drawings, you know what you're dealing with a little bit. But when we're talking about my 95-year-old hotel, we had ideas where pipes were going to go, but we couldn't actually open walls because when you've got 1,300 guests in the place, you don't cut open the stairwell until you have to cut open the stairwell. So you find things, you adapt along the way, and you need to really make sure you pick the right partner to do that with, or your change orders get a little out of control, and then the people above signing off on the extra costs get a little bit upset. So yeah, retrofits are fun.
Fun, yes. Stephanie?
I think this works now. Yeah, that works. Okay. It just took a second to warm up. My name's Stephanie. I'm an engineer with SES Consulting. So we do exclusively retrofits. We are the partner that helps work through all of those things. So we do mechanical retrofits, a lot of controls and commissioning, which I'm sure you'll hear me talk about a lot on this panel. So yeah, I'm the engineering side.
That was way too short.
I'm just introducing myself.
Now for something different.
Yeah.
Good afternoon. First, thank you to AutomatedBuildings.com and Cochrane Supply for hosting this panel, and thank you to the other panel members. My name is Daniel Caldwell. For the past 2 decades, I've worked for a company called Belimo, and Belimo is the global market share leader manufacturing peripherals for the building automation industry, including damper actuators, control valves, sensors, and meters. My role, actually, my job title has the word retrofit in it, so I think I was a shoe-in here to sit up on this panel. But I lead the Americas in terms of working with owners and operators and just increasing the impact and the rate of retrofits in their built environment. So we're strategically aligned and focused, and Belimo's uniquely positioned to provide the training, the support, the resources, and as well as the tools like thermal energy transparency needed to really make impacts in the built environment. I think Brad said earlier that retrofits are messy, and I thought there was a lot of wisdom in that very simple statement. For the past 20 years, I've been trying to explain to my parents what I do for a living. They have kind of just concluded that I fix air conditioners. That's not really where we're at here this day, but it is a sense of purpose, right? And or it's more tactical, I think. I have a little bit more than that, but generally speaking, to think about the playing field of what we're looking at today in terms of the challenges and opportunities, take a look at the time frame from 1960 to 1999. So over those 4 decades, we felt like the rate of technological innovation was going at breakneck speeds. Right? In 1960s, we went from touch-tone or rotary phones hanging on a kitchen wall to touch-tone, and you could actually use a computer. It was a mainframe that was the size nearly of this room, and it cost a couple $1 million. Fast forward to 1999, and we updated and innovated the technology to a Nokia 5180, if you remember those cell phones, with T9 texting to increase the efficiency of how we could communicate. We had compact Presarios, these low-cost PCs you could put in every home throughout the country. And we had 28.8 kilobytes per second dial-up internet. So we were really on the forefront at a breakneck pace. But obviously, I'm being a little bit sarcastic. When you look back over the last 25 years, that technology seems kind of rudimentary and basic. Over that same 4 decades, though, over 50% of all the buildings that exist today were constructed. And they were built with the technology that existed between 1960 to 1999. The thing is that buildings are sticky. They stay around a long time. 80% of the buildings that exist today will exist in 2050. We don't knock these things down. We just put Band-Aids on them. And a lot of times those Band-Aids don't fit. So to summarize, basically I'm done telling my parents what I do for a living. Like, I'm past that point. I've got young kids at home, 4 and 2. And I've explained to them what I do, and they kind of get it more than anyone else. They say, Daddy's a doctor for sick buildings. And I just kind of live with that. So
I'm going to start the Q&A a little early just because I've got a question for you, Daniel. So as a product company, Belimo, just maybe briefly, how do you guys approach the retrofit market that's different from how you're approaching the new construction market? What are some of the key differentiators there for you guys?
Yeah, we call it a strategic initiative because strategy is where the money goes, and we look at this globally. So this is actually part of one of our overarching global investments at Belimo. New construction, we have a lot of resources existing to really help support the entire infrastructure of people and stakeholders that are integrated in making that happen. And a lot of times you can replicate success more scalingly. With retrofit, it takes a lot of hand-holding, and it takes a longer-term perspective as well. These things aren't fly-by-night. Projects seem to happen very quickly, but the real development of that should be going painstakingly slow. And it takes knowledge, it takes people, so we hire a lot of people, and it takes services. So it takes people on the street that know what they're doing, really support through training, and entire product development cycles, as well as having more people available to influence and help the entire ecosystem. And it starts with the operators, and it goes all the way up through the engineers, the systems integrators, everyone. I mean, we have to touch every single aspect of that, and that's where we're investing.
So lots of babysitting.
Those are your words.
I think you said hand-holding, so yeah. And last, certainly not least, Chris, why don't you?
Thank you. My name's Chris Saltz, and I do fix air conditioners for a living. Only mechanical contractor, I guess, on the stage up here. Just had my 5th grandchild a couple of days ago, so I think that makes me the oldest up here as well. And I think that, and again, I'm with Couts Mechanical in Southern California. We do work throughout California. We're $50 to $75 million a year. About half of that is existing building work, so we get involved in a lot of retrofits. We're employee-owned, 100% employee-owned, been around since 1978. Handful of our employee owners here in the front. Thanks, guys, for the support. Really appreciate that. I made them come. I just think that, innovation is key. I mean, if you're not innovating, you're probably commoditizing your way out of business. If you're just keeping up with the pack, then, you can be the low bidder and, maybe break even. So we're in the money-making business as employee owners, so we have to innovate, and our customers are kind of expecting this stuff. I mean, I just checked my heart rate because this little thing on my finger tracks my heart rate. It's over 100 beats per minute right now, which I think indicates I might be nervous. Of course, it was 100 beats per minute walking over here. That has something to do with this, but yep, that's who we are.
Okay. Great. Just keep in mind, ask questions anytime, but I've got a number for these folks, so I'll get started here. But I think, and go back to something you said, Joe, because I think one of the hallmarks of retrofits are you run into the unknowns, right? Like you don't have, as you said, a blank slate that you can solve all the problems on paper. You got to kind of knock open a wall and see what's behind it. So how do you cope with that on a project? Because I think you even alluded to it. If you don't go about it the right way, you're looking at endless change orders, a budget that goes through the roof. But you've obviously encountered this. How do you deal with it on your projects?
Yeah, I would say the best way to start out is to get the right people involved early on. We like to bring our general contractors to the sites when we're doing a lot of these things. So we just don't have the engineers drawing things on paper. We've got guys there who are like, whoa, guys, if you're going to do this, have you checked this and this? And get some guys in there to punch some holes in walls where it's possible. Make those assumptions more reasonable so you have the right budget for the project. You need the guys to go in and look at the electrical panels where you're going to tap in. Make sure that you can still buy components for those. Sometimes that doesn't show up until later, but still miss some of those things. But one of the nice things about existing buildings is you do have a lot of stuff that you don't have on the new buildings, and that would be data. If these buildings have been around for a long time, you do have a lot of information about them. So utilizing that stuff as well it can help you mitigate some of your risk and reduce some of your costs in a lot of cases. I've never gone in and done a retrofit where I put in a lot of cases heat pump systems the same size as the boilers. Boilers were cheap and easy to put in. Heat pumps are not. So it's a good idea to know how much heat you actually need in a case rather than going in and saying, you know what, I'll just put in like for like, because you can quickly even talk to the operators if you have no other data to say, yeah, I never fired that second boiler up until even on the worst day of the year, it never gets fired up. So you don't necessarily need that, or maybe you leave one of those boilers in place and for resiliency measures and never utilize it because that boiler is $100,000 and the equivalent heat pumps might be $1 million. So I think there's challenges on both sides of it, but take the challenges where they are. If you've get as much information as you reasonably can, get the right people involved. Make sure you tender things properly as well. If you go out to the lowest bidder on an engineering project and they don't know what they're getting into, sometimes that shows in the amount of hours they can dedicate to the work. You need to make sure you're working with somebody and you have an open mind to, hey, you know what? I need to do this engineering up front. I'm going to make sure that I have the right engineer and everybody knows what they're getting into here. Otherwise, you get some shortcuts sometimes. And
you mentioned bringing a contractor to site. Even pre-design, how are you engaging them, or is it just somebody you've got a relationship with? How do you find that contractor, and how do you actually get them engaged, even pre-drawings?
Yeah, in a lot of cases we have preferred contractors we work with on other jobs. Sometimes we'll bring them in. The size of the job will depend on whether we can go to them or whether they're tendering. But if we've got a good relationship with them, getting them in off the bat to say, hey guys, can you take a look at this? Sometimes we engage them up front. We arrange a contract as such that it's fairly open book. We know what we're getting into. We'll subcontract or subtender the trades, and all that comes through open book. We just get them involved because we need to make sure, we need to leverage their expertise. So generally it's trusted partners that we bring in, and somebody with history on the building ideally, so that we're not going back to square one. We'd rather go to our base building engineers and the base building sort of contractors that know the place, because those are the people who are going to bring the most value to the table.
Chris, I'm interested in your perspective so at the owner side, from the contractor side. Does that look similar to you? Like what?
Yeah, same thing. I mean, we have a service business for that specific reason, because they want us to be there after we finish a project. They want us to be there for the life of the building, to keep the data on the equipment, be ready for the next replacement. We're in a few interesting retrofits right now. We've done the fan walls, we've done the heat pump jobs. We're always looking for that next thing. We've got a couple projects right now with a interesting dehumidification technology that's we've got NREL, the National Energy Lab, out there for the past year, 60 to 70% savings on this. And it's really a simple heat recovery, runaround chill water loop, but it's some AI software that's running the chill water valves and rescheduling the boilers and chillers and stuff. So we love getting involved in new stuff like that, and then rolling it out to the next customer. And early on, if we don't know the building, if you're familiar with Open Space AI, we'll walk the building with a 3D camera so that our whole team back at the office can, walk the building and get familiar with it. So we have some efficiency tools to kind of jump ahead.
Cool. And I mean, I think, Joe, you kind of described, if I was to put a name to the process you described, I often call it like an integrated design process, where it's not just the engineer, but it's the engineer, the controls contractor, the mechanical contractor, getting together as early as possible in the project. And that's how we like to work as well. Ken, I don't know, like Steph, you want to talk about that from the engineer perspective?
Yeah, so I mean, the integrated design process has many iterations depending on what you're allowed to do. If you can sole source, great, you can do the whole thing. If you have to go through a tender or bid process, you can't do the whole thing, but you can do parts of it. And so we work with, public sector, private sector, all across the board. And I don't want to say it's, integrated or not. It's more like the more of the integrated process you can use, the better outcome you're going to have. So, for example, we're retrofitting 2 multi-unit residential buildings. I think they're $10 and $12 million retrofits, so fully electrifying. They can't sole source. They're publicly owned. That's not an option. But we have done it as integrated as possible. So we have the envelope engineer, we have the mechanical, we have the electrical, we've got someone in construction to ask, we've talked to other contractors. And sometimes what we do, because we have to go out to tender, and there can be some rules on giving preferred treatment or whatever. If we have an existing relationship, we'll talk to them, and sometimes we'll pay them a couple hours of their time, so that they don't feel, and now I have to get preferred bid. Like, just getting the contractor involved, however it's possible. If you can just tell them and get them involved and then they can bid, that's also great, but sometimes rules don't allow that. So as integrated as possible. And I would say the other big piece of the integration is the existing building operations and maintenance team, because again, we work with a vast array of different building types and building owner structures, and I have some where it's great. The operations team and the BAS contractor and the mechanical contractor and the consultant, we all chat. Something goes wrong. Oh my gosh, this actually doesn't fit, and we found out this thing, the domestic hot water piping is corroded, and we have to redo it, and things change, right? With a retrofit, you can never know exactly what's going to happen. But when you have that team and you are integrated and you have developed that trust, it tends to be less finger pointing and a lot more of like collaboration. Whereas when you have it very siloed, which is still quite common, where the operators are quite separate and sustainability is separate and, maybe the engineers are in their separate departments, it ends up with a lot more finger pointing and it's not as efficient to resolve. So given the choice, I always recommend, can we do an integrated design process? Can we do half of an integrated design process? Can I talk to the contractors? If you already have a preferred mechanical or BAS contractor, great. I'm going to skip right to that. And I'll call them up and I'll be like, this is what I'm thinking. And they'll be like, oh, it would actually be better if you did it this way. And I'm like, great, let's do that. And then at the end, we have a design that's actually going to fit through your door and is actually going to work, and they're going to be able to maintain it because you gave them the clearances to get around the system. So I feel like it's really not an all or nothing. Some of you can do all of it and some of you can do some of it, but the more integrated you can be, typically the better the outcomes we see.
Yeah, and I think that's, I think underscores sometimes the creativity in retrofits. Like as engineers, hiring contractors, not the owner, but we'll hire them just to be our advisors on the design. Because I don't know how to run a pipe from there to there, and I can tell you the length, but the best path, or what's going to be, which wall is easiest for them to core through, that's where you need. No engineer is good at that stuff. That's where you need the contractors, the people who actually have to run the pipe, do all of that. That you kind of need that perspective and how you get it. I think as Steph said, sometimes you have to be creative about the business relationships that you create on these projects. I don't know, Daniel, anything you want to add on?
I think you guys nailed it.
Well, where would Belimo get involved? Where would you guys get involved in that process? So everyone's getting together for a nice kumbaya before the project. Where do you guys?
Yeah, our mission is to get involved as early as possible as well. We can help in a lot of different ways, and it really depends on what the goals are of the project and what scope you're trying to do. So often we're getting involved because you have kind of the deferred maintenance, you have reactive maintenance, you have proactive maintenance type retrofit projects, and then you have this continuous improvement thing. So often I think players are just coming to the table too late. Something's broke, we got to fix it. Everything's on fire, and that it just equates to money. Really, when we get in early enough, we advocate towards approach of transparency and really understanding where your thermal energy is being wasted or consumed. And if you can get in there with the right diagnostics and the right approach between collaborative partnerships, you're no longer looking at just a maintenance project. You're looking at a continuous improvement opportunity. I think our economics in our industry are a little backwards sometimes. We measure conservation energy measures with simple payback period, which is, Brad, thank you for laughing. You might.
I calculate a lot of simple paybacks, and I agree.
Yeah, so simple payback has become the de facto standard of ROI calculations in the industry, and the first thing they teach you in finance school of any institution is that it's the simplest for a reason. It's also the least likely to provide a good outcome in the long run. So I think often there's opportunities to really scale and plan retrofit projects early on that will pay for future improvements and the reactive stuff later down the road. So the more you can save with less early, the more you're going to have capital and other funds to improve more later.
Yeah. The other thread I just want to pick up on, I think it was something, again, that Joe, you mentioned was, retrofits are different because you have data on the building. So you can get data often on, and we do that all the time, what are the trend logs, the heating, cooling system, how often is the boiler fire. I think there's other kinds of data too, just in the history of, let's say if you had a building operator who's been there 10 years. As a design engineer doing a retrofit, I would want to talk to that guy and know everything that he knows about the little quirks of his building, or to go talk to the controls contractor. Going through the code, notice, hey, there's a line in that code that says, never let the outdoor air damper go below 50%. Okay, why not? The doors all blow open as soon as we do that. And then, okay, well, there's a pressurization issue. Now we can figure out, look at ductwork size and figure out how we might solve that. But if you don't go digging through that data and ask the questions and talk to the people, you're not going to find out all of these things that you kind of need to know make these projects successful, right? So, any questions? Yeah. Yeah.
Engineers, you go by your specs. So on that specifications, that engineer specs, let's say 50,000 BTUs. So basically, you're putting in what that spec is, okay? So we put in exactly what that spec, and it doesn't work, okay? So that's when the fingers start pointing. So,
Yeah.
okay, I know. Besides that, okay, this is retrofit.
Yeah.
As the engineering department, there's other stuff. Okay, say if it's a water cool, how much prep do you put in for like tab reports and air balance reports before you guys do that calculation, before you start designing, prevent any of that to happen, and electrical distribution? Because you know what, sometimes a lot of that's not done, and that's what creates a big issue and friction point between the contractor and the engineer.
So I've got a story I'm going to tell too. I think goes along with that point. So we were putting a new domestic hot water system, the roof of a 100-odd unit apartment building. We're going from gas to like heat pumps with gas backup, kind of complicated. But anyway, we had to run new electrical distribution up for it because we needed more power. I've hired an electrical engineer as my sub. They did drawings, showed where the path where the cable was going to run, tendered the job, got it awarded. Contractor shows up in site. He's like, I can't get my coring equipment in that closet where you wanted to run the cable. Engineer didn't think about that. He didn't think about the physical aspect. And so now the job's been tendered. Okay, well, what do we do? Okay, let's find another path. It turned into a 3-year nightmare to get power because then we had to run through an exit stairwell and build a fire-rated enclosure, and then we didn't have enough exit room anymore between. It was just one thing after another, all because I consider a pretty basic piece of due diligence was it. So I hear you. I've been on the other side of that. So I mean, yeah. You did what you were told. Yeah. No, and I didn't mean that to say that. That was on the engineer, 100% in my opinion, to figure that out. But I think
we're kind of running out, and it's like, okay, we need to submit some change orders, and that's where all this craziness starts happening.
Yeah.
So I'm just, seeing.
I think. Well, I think. So I'm not on the panel, but I can give you my opinion because I have one. A lot of engineers don't do many retrofits. Retrofits are a little thing they do on the side. Well, they do, and I think that's where on the engineering side, like some education, like we need to change that aspect. Like an engineer who's used to designing new buildings can't just walk into a retrofit job and expect to approach it the same way. And they do, and that, in my opinion, that's a big problem. So I think that's professional standards on the engineering side. There's got to be some practice guidelines and things like that put out there that said, listen, retrofits, because I don't think they realize the mess that they're going to get into. And so that's one piece of it for sure. But I'll hear what the panel has to say, but other.
I might just add, absolutely. We see this all the time, and I've been brought in on a lot of jobs where it's like, I had this VRF installed, and I have this gas backup, and the VRF isn't working at all, and everybody walked away from the project, and now I've spent $3 million and it's not working. And so you're right. It's not on you. There's no way for you to know that, oh, well, if you did the balancing, we actually have low flow and we should have done a balancing report and that system isn't going to work and the design wasn't done properly. But what advice I would give you while we're working on all the practice guidelines and getting the engineers up to speed, because I will tell you that is happening. We just wrote a big report for all engineers on how to support with retrofits, and there are things happening in the background. But in the meantime, as a contractor, and I know you don't always have the time to do this, but I have recently had some contractors come to me and be like, your design is not good. It would be better if you did it like this. And I'm like, amazing, that's better, let's do that. So I would encourage you to push back a little bit on it if you can and just say, what about this? Because again, that's that integrated design process. Like, I actually want my contractors to tell me if they think that my idea is bad. I want them to say, oh, I would write the code this way. Oh, I would put this pump over here. I would do it this way. And so that is that integrated design process. It's back and forth. And I recognize it's hard at tender, but I just tendered 2 domestic hot water heat pump systems. And I had a contractor give me a call and he's like, so I know I haven't won this job yet, but I just really don't think that you want to do it this way. And I don't think we want to have a buffer tank because we're going to get this temperature stratification and we really need to move, like we need to do this way. And lo and behold, we're doing that and we've saved a bunch of money and it's so great. And that would be my advice.
So you come up with your own engineers to go and
Yeah.
assess that. Okay, so that, because there's money involved, because time is a lot of money to do that researching, because, you know, we come to like projects or whatever, especially with air, like with certain buildings, people tie into it, you know, and so you put another redoing an air handler, and it's like, hey, we're still starving over here. Oh, they didn't show this in this room over here and all that other stuff.
Where'd that damper come from?
Like
Yeah.
just little stuff before would help the contractors out.
Yeah.
The engineers would just have that before report, that tab report.
Do some testing.
And afterwards,
Yeah.
you know what, then we know what we're dealing with a little bit better.
Yeah.
If you don't do that and we'll do it. We'll bid exactly what you're telling us to do.
Yeah.
Because we want to make money too. So, but we don't want to do that job and have a whole bunch of headaches and people say, hey, it's not working. You don't know, your team don't know what you're doing, but we got a kick butt team, and it's just part of an aspect that you guys left out or missed. You know what? So now everybody's trying to, kind of MacGyver to get this thing working, and it's always a money pit after that.
I mean, I would say especially like a lot of the big engineering shops, like they're just going to take whatever drawing sets available to them. That's what they're going to start with. But, you know, as you said, all the TIs that have happened over the years and all the changes, like that's not on there. And then somebody's got to deal with it. Yeah.
Prep work before you start that bid.
Yeah. Joe?
I was just going to say, from an owner side, some of that falls back to the owner. I should have disclosed I'm also an engineer. So I get more actively involved sometimes than the other engineers would like, and I push back on them from an owner's perspective. But also, owners have to go into these retrofits knowing it's not new construction, knowing that, hey, you know what, if we don't have a tab report and we're not willing to pay for one up front, then that's a risk on our part that could cost us down the road. So yeah, not every ownership group has somebody like me who can translate back to them to say, hey, no, these guys are right. We got to pay the extra money. Deal with it. And that falls back on me, and I get my hand slapped if it happens too often. But you have to have some flexibility built in, because you know there are things out there. It's not going to be perfect tender every time in retrofit.
I just have one more thought on that, because we've had this happen on the engineering side, in that we've had clients who are like, I want the low bid, I want it, the design the way that it says it's going to be, and we're like, well, we need to do a balancing report, or we need to do this extra work up front, or this step is required, and so naturally we're not low bid and we don't get the job. But then that client comes back to me 2 years later and is like, my system doesn't work. And so eventually they come back. So perhaps, and what I'm seeing now with my clients is there's this like really, if they trust a contractor, they are willing to pay a lot more for that trust, because what a lot of them have had is they've been burned by the low bid.
They've been burned a few times. Yeah.
Yeah, they kind of learned their lesson the hard way. They figured it out, and whether it's the contractor or the engineer, they've stopped working with certain people because they've found out that net it's actually not cheaper. So what I would do perhaps in a contracting situation, which is what I do as an engineer, if I'm like bidding a project and I'm like, I know I'm not going to be low bid, but I don't want that project without a balancing report, without that. So you start speccing that, and eventually they'll, come to realize that, okay, well, they know what they're doing, And I would rather spend a little bit extra money up front, because I've seen a lot of owners, like a lot now. I would say probably about 25% of our business is, I did this retrofit. I was promised these savings. It's not delivering. Help. And then net, it's costing way more. So that is also happening.
All right, another question? Yeah. Yeah.
You talk loud.
A mic is coming, but slowly. Yeah.
So every time I'm faced with a retrofit decision, I generally have a choice between recommending old technology that's typically like for like, and like the owner nods their head at that option easily, and then we always have the opportunity to like present them usually with a newer technology. Heat pumps are for sure the item that we're thinking about all the time. The problem is they don't always pencil out, especially with initial costs. So it was mentioned earlier, like providing complex return on investment calculations. Can you describe a little bit more about what those investigations look like? What are the metrics for where you tell your customer, yeah, you're not going to win on the new tech on this one. Like, let's just go back. Let's just stick with like for like. And then when are you practically begging them to spend the more money and get the new thing?
Do you mind?
Yeah, start Daniel.
So great question. We actually have a pretty good examples going on right now in Ontario. We have an owner that is pretty proactive in their product lifecycle maintenance, right? They're proactively changing out peripherals before end of life cycle and the terminal units, kind of to minimize tenant disruptions, right? So they know that these things are moving parts, they're gonna break at some point, and they're kind of wholesale project, changing out them all out at the same time. It's not a huge project by some of the standards here, but it's a couple $1 million. And the technology they're using was invented in 1990s, right? And they're going to go like for like on this project. Now, the contractor called us and said, "Hey, these things look brand new. What's going on? Like, can you please come help and provide that?" So, I think the first thing to look at is not just to use project economics and finance calculations, but really the depreciation of the total product life cycle costs. And I think we see a lot more awareness with end users to really look at what that total cost life cycle is. So, we depreciate buildings. Unfortunately, buildings change hands quickly, so their orientation isn't as long-term as the depreciable asset is often. But in terms of a contractor, I think you're basically carrying the overhead of that labor regardless. And labor costs tend to be the overwhelming largest majority of a project, not the actual products being installed. And a little bit product dependent. If you're putting in a maglev chiller, that's kind of expensive. But in this example at least, the labor is 80% of the project cost. So again, we're all playing musical chairs and the floor is lava, right? Nobody wants to get caught with the last chair. There's a lot of risk, whether it's the load calculations we discussed earlier and the challenges there. Nobody wants to size too small, right? And so forth. Really, the new technologies, the value isn't extreme. It isn't always on an energy savings. The new value is really in terms of data and transparency and how it's communicated and integrated, right? So that's hard to measure, and there hasn't really been great calculations for that, so to speak. But the examples are evident. When you put in BTU meters distributed throughout your building to see where your thermal energy loads, we're finding supply and return pipes backwards. We're finding blind ducts with bypass valves wide open. We're just throwing hot water into chill water all day long. These things have been going on for decades. You do the math on that calculation, like the labor, nothing matters anymore. We're throwing away money. So really, it's hard to get the mindset of just pure project economics evolving to product life cycle economics, to really evolving on what is the impact and what's our strategy with data, transparency of thermal energy transfer, an identification of not only the risks today, but the future risks, and that kind of the existing building, like the monitor-based commissioning, this continuous cycle of that asset. That's where the leaders are moving. It's just not fast enough, and we need to help.
How do you keep up with, since, AI technology is moving so fast, this BMS, this retrofit software, your software is getting so, I hate to say it's like obsolete within like 3 years, 5 years, every time there's a new system upgrade. How are you doing that, those type of styles of retrofitting in your BMS systems? What are you doing in that aspect? Do you work in that aspect of getting into that style of retrofitting too, with older styles versus new and to integrate in with that too, or what was your trick?
Yeah, I mean, I think the future is unknown right now, and the evolution of technology with AI is at a pace where it's really unprecedented. There are a lot of companies out there that are making really big promises out there to be disruptive. The building landscape, moving from the BIM world, which maybe largely wasn't as transformative as promised, to now this ecosystem of digital twinning, right, and modeling buildings in a virtual environment. I mean, at least from a manufacturer that makes the things that move, that makes the things that sense, right? We're a critical component to all of those systems, and really our strategy is just to be the easiest to work with, right? We're going to work with those folks, and we don't know who's going to win, but we want to be the easiest to plug in and just talk back. Again, the value is in that data and getting it back and getting more of it, because you look at, I've had the luxury of my career to be involved and go into the class AAA marquee buildings throughout the Americas over 20 years. And these buildings are beautiful, and they're on posters, everything, and they're famous. And the dirty secret is you walk in and they have, everyone has a BMS system now. And then there's a piece of paper out there that says, if it's 72 degrees outside, do this, So building automation and so forth, there's so many opportunities out there. I think just within the building today that the future is bright, but there's a lot existing today that we can really impact that will bridge us to these great promises.
The building's still half full of pneumatics. AI is not going to do a damn thing.
That's right. And every building still has a pneumatic compressor running. That's just empirically my experience.
I mean, the new BAS systems that we're involved with are all cloud connected. So it's kind of like your iPhone. I mean, it's getting updates in the backgrounds and keeping up with some of that stuff that seems like, we don't know what's coming next year. So yeah, we've got some cloud connected building management systems that are getting updates, and on top of that, putting a fault detection or another cloud dashboard on top of that. Yeah, that proprietary, that's a whole nother discussion.
Yeah. We have other discussions on that too. We come back to some other sessions.
That's all. I was just trying to pick your brain and see how you go about it and help myself out,
I think the big problem to solve, especially in existing buildings, is get the hardware side sorted out first. Get rid of the pneumatics, get the right sensors in place, get rid of those old valves that can't communicate, put in some nice new valves. Because if the hardware piece is sorted, then you can put whatever software you want on top of it, right? And that can evolve very fast. The hardware can't evolve fast. The hardware is sticky.
Yeah, I would say with the hardware, you're looking at a 20-year plan sometimes. And back to the question about how do you sell that business case, depends what the owner wants for the building. If it's a long-term hold for any of my buildings, I'm not putting a new boiler in it because that's going to be on the books for 20, 25 years. And I know I'm going to be made to decarbonize in that time frame. It's not the hugest push for us right now. Anywhere where we can band-aid things, get a couple more years out of it, we're doing that, and just in this current environment. But we're not taking steps backwards. I'm not going to put a mid-efficiency or even a high-efficiency boiler into one of my buildings. I'm taking that next step. When my boiler's dead, I'll put in my heat pump. Same with pneumatics. I can't go through a 2.5 million square foot complex and do all the pneumatics in that place because it's going to be $10 million. But every time a tenant turns over, that's when I'll hit that floor. And yeah, I've got buildings that I have JCI, our older systems running and controlled by an open source Tritium Niagara system. There are translators, so you can do this gradually. You can get around some of this stuff and make the numbers work, but that's what's driving it. So that's my challenge. Getting the building from where it is to where I want to be, having that plan put forward, and then figuring out the steps that will allow me to get funding for those things.
Great. Yeah, question there.
I'm still pushing the decarb stuff. It's just trying to figure out the best way to get there. A lot of I'm based out of Toronto, Canadian assets. We had a carbon tax in Canada a year ago. We don't anymore. That hurts the economics. Electricity prices have gone up quite a bit in Ontario, and gas has gone down because the carbon tax has gone away. That hurts the decarb economics. But it's a temporary thing, in my opinion. When we're looking at the long term, a lot of the larger corporate clients still have these environmental goals, and we're on a clean grid, so it makes sense to decarbonize and through electrification. It's just making the economics work, and it's always going to be more. Everybody's looking for this payback. It doesn't exist. Like if I can make a building run off of heat pumps for the same as what I can make it run off of a gas boiler, I'm winning all day long. And the equipment's probably going to cost me twice as much at least as if I'd gone back with boilers. But I think it's the right thing for the building, and we've convinced our senior people, the C-suite, that they're on board with this plan. Like they're going to take those steps towards to getting to where we want to be. I know when I sold it, I'm like, okay, to our CEO, are you okay if I never put in another gas boiler? And he came back with, yeah, and don't put any kerosene lanterns in either. We're done with them. Move on. So like you just need to have that mentality and then try to make the economics work to get there. I'm looking at all kinds of things to be innovative and make economics work, putting data centers into my buildings, using waste heat off of those to heat the building, make somebody else pay for that expensive electricity. Problem is it's expensive electricity, and there's only certain data centers that will go in there. So just trying to think outside the box, downsizing the equipment, making it as small as possible, backing it up with boilers, pushing the energy modelers to push it to get to where I need to be. Those are all things that make the numbers work better. And then picking off the energy efficiency stuff we've all been looking at for a long time. At the building that we're working on in BC, we had a year of going and retrofitting the controls before we even started the plant to reduce energy use and size the plant properly. That kind of stuff plays well. Like we've got a whole lot more comfortable building. I think we tripled the number of zones on each floor. Our tenants are happier.
Still have single pane windows.
Yeah, we still managed to keep the single pane windows because those are too expensive to replace. But
might have a solution for you.
Okay.
We'll talk. Yeah, question.
Technology choices, right? Putting in a boiler versus the heat pump and the additional cost. If you make the decision on that heat pump, what are some of the kind of behind the scenes benefit? Does that increase the value of your property? Are there different depreciation schedules for boilers versus heat pump?
I wish those economics existed. They don't yet. We've talked a lot to people about what that does to the valuation. The long and the short is if people are more likely to sign a lease in your building long term or stay in your building, then that will help. I have 1.4 million, almost 2 million square feet of zero carbon certified building in downtown Toronto. I have tenants like Amazon and a whole bunch of large people who care about that stuff. Are they paying me more rent than the neighbors? Probably not, but I'm 97% full in that building right now, which is probably better than some of my neighbors. Is that because of my location, because I'm in a great location to some degree? The market's pretty good for AAA office buildings in downtown Toronto right now. But those sort of things help differentiate you in the marketplace and will eventually make it to the evaluation side, but you need to have some sales. And before people put value to anything, you need to have some transactions. So if zero carbon buildings start selling for 10% more than non-zero carbon buildings, the same sort of things when they're LEED Platinum certified buildings. It's kind of a softer valuation, but you get a bunch of transactions happening or lease rates and things like that, and people run the stats and they're like, oh, people are paying more for this stuff. Right now, it's not there. It's a risk play for me. If I put in a boiler, it's going to be on my book for 20 years, and then the City of Toronto passes legislation in year 10 that says I need to not use gas or I get hit with this giant tax, and I got to put in a heat pump then. And the economics of that looks a whole lot worse because now I'm still trying to recover these boilers that are now resiliency, and then I'm paying for the heat pumps as well. So it's a risk play for us right now more than anything.
And just to add, that's a great explanation. In the U.S. and some major municipalities, the economics are changing. Local Law 97 in New York City, BERDO 2.0 in Boston, Cambridge has theirs, BEPS in Washington, D.C., and BEPS in Seattle, Title 24. There's actually real cost to carbon now that's being impugned on owners, and we're consulting and helping these folks through this pain struggle, and they're not as proactive as Joe has eloquently anticipated. So with those numbers, there are a way to do risk modeling now based off these leading cities in the U.S. on how to do the economics. So the economics are starting to play out now, and you can actually show a real meaningful risk analysis because everyone that's now chasing this, they're losing sleep and having town halls and taking mayors out to dinner, very expensive dinners. So.
Maybe just one more thing on the economic piece, because we've talked a lot about the life cycle and what we'll do. Again, like Joe said, you're often not going to have a positive life cycle, net present value, any of it. Like, it's just not going to play out. But what we do for our clients who are looking at impending carbon penalties is we'll do the life cycle analysis. So we're going to look at the entire system over the life cycle, and then we're going to compare that to what the carbon penalties would be, and it's less, then that makes sense. Or, for some of our clients, they're like, well, we're going to purchase 100% renewable natural gas. So if the project, like, installing a heat pump in their terminal water source heat pump loop, it's a better payback, not payback, but, net present value. It's a better opportunity than buying 100% renewable natural gas. So we're kind of looking at the options. None of them are going to make you money, but one of them is going to make you lose less money, and that's the one you're going to pick.
Yeah, the goal is often to find the least cost path to low carbon, not the one that's going to return money to you, but it's going to cost you the least. And it's kind of a mindset change for energy, right? Because usually we're looking at, simple paybacks ruled forever. We have to think about these big, more complicated projects a bit differently. I'm going to take the privilege of being at the mic and ask a question that I want to ask before we are getting close to the end now, but I want to talk very briefly about commissioning on these projects, because I think commissioning often gets overlooked, often not, there's not enough time allowed for it at the end of the project, and my opinion is that it's crucial to the success. So I want to know, how do you make sure the commissioning happens on your projects? And I'd like to hear each of you, actually. So maybe, Chris, let's start with you.
During my years at Johnson Controls, it was people, process, and tools. I mean, it was those three things. So you had to hire some, pretty sharp people that understood commissioning and the commissioning process and how systems worked and things like that. And then, we had good processes for that. And then the tools that you're using, John says it was focused on the Metasys tools or whatnot to automate some of the commissioning. As a mechanical, we're using a different tool, but a software tool nonetheless that we can commission the building with more efficiently, document, automatically all of this commissioning process, and then some data that basically lives with the building, helps us and the building owner manage the warranty risk and monitoring maintenance and things like that as well. So it's people, process, and tools.
If you get let's say you're working on a project and you see that commissioning hasn't really been included, is that something, will you have a conversation with the owner about that, or?
Yeah, I mean, and in California is part of Title 24, so there's always a third-party commissioning agent on every project. But what we don't usually see is an actual commissioning plan, which makes it very difficult for us to price our piece of that, which is the support of the commissioning. You know, is it a one-page plan? Is it a 300-page plan? So,
and how do you deal with
that's
that?
the tough.
How do you deal with that?
We RFI and ask some questions. I mean, you got to get that sorted out, you know, in advance. If you're taking risks like that going into the bid, that's just silly.
This is a good bar topic. Great question. I mean, I have a lot of stories on commissioning, and you know, we used to fight over what retro commissioning versus recommissioning was and which one to use which. And ASHRAE finally said, just call it existing building commissioning, right? And then we used to say continuous commissioning, and then we can't say that, so we have to say monitor-based commissioning. It's just a fun bar talk, but I see a lot of owners that invest in the value of this, and you really see the results. I think especially with the right partners, you know, contracting and engineering, you know, service contracts are a great way to leverage kind of this continuous commissioning mindset, right? But really having an engineer and a plan, or you know, design build, or whatever your path is. We have a example of a building in Chicago. I can't be too specific, but they were up for a very big award by an organization, and they actually did a really deep retrofit in 2020. It's a historic building, and they spared no expense. Maglev chillers, ERVs, you know, they even upgraded the windows, believe it or not, in a historic building. And so this building was top performer. You know, I mean, in terms of energy utilization index, it was unparalleled. And but they wanted to win this award. So, you know, 5 years later, this year, they decided to work with an engineer to do kind of this commissioning project, and said, yeah, we know we did this deep retrofit 5 years ago. We've got all these cool products and transparency. Can you come out and kind of help us with our sequence and just kind of tune up the building? So we got to work with the engineer directly. Our products were installed, not a commercial. They just happened to be there. And so through just some intelligence and kind of understanding what was going on, the building was running super great, but they were wasting, they were leaving $170,000 a year on the table for the last 5 years. And this was a very expensive retrofit. So they got that tuned up, and hopefully it's a public story sometime soon, but they won their award. So there's a lot of value there.
Jeff?
Yeah, commissioning. This is kind of a constant conversation with owners, and it often takes being burned once for them to see the value of commissioning and invest in it. So it is something that we do because we come from a controls background. So that's something that, you know, as a mechanical design engineer, we do a lot of. However, I have looked at other mechanical design engineers' scopes, and I'm like, oh, there's like literally no line for commissioning at all. And they're like, oh yeah, well, we don't put it in because owners won't pay for it. And so I think there's this big shift, and that's one of those things that you really need to push the value of. I'm working with a client right now who he's doing some dual fuel rooftop units, and I do a lot of teaching. So he came to one of my presentations where I was talking about this client who installed these dual fuel rooftop units. They were supposed to save 50% of the energy. They're actually using 11% more because it's cycling between heating and cooling, and it wasn't commissioned, and the set points aren't set up. And so he was like, hey, I really want to do commissioning when I install these because I want to make sure that I'm achieving my savings. But I got a quote from an engineering firm to do, you know, support with these dual fuel systems. It was, you know, gas-fired rooftop unit. We're putting in dual fuel. And it was, you know, $80,000 for 3 rooftop units. I can't afford that. And I was like, well, you know, I don't really need to be involved in like the sizing. You're going to go like for like a rooftop unit. I don't need to be installed in the construction. I don't even really need to be installed. Like, I need to maybe give you a performance spec to say, whatever type of rooftop unit you select, it should have these options. It should have a damper that modulates. It should have, you know, some of these things, but I don't care what size. That's pretty minor. You're going to do a bunch of them. I don't need to size them all. So we actually decided that instead of having an engineer do the design, do the construction, do that, all I did was a performance spec and commissioning. And so now the cost is $10,000, and he gets the performance because, contractors in a lot of cases can do it. We don't need to be there. But where it's really helpful to have the engineers is the commissioning. So sometimes when I think of innovative, it's not necessarily like a new technology, but it's like, I have this amount of money. I want to make sure my project is going to work. How can I use that money most effectively in the area that is most going to make an impact? And most of the time, that's on commissioning.
Commissioning plan is worth more than a rooftop drawing.
Joe?
Sure. I'll also disclose I was a commissioning agent for 6 years. Spent a lot of time on rooftops doing rooftop units. So if you don't do it the day they're set up there, they will be that way for the rest of their life because no one will ever go look at them except to change the filter, maybe if you're lucky. Yeah, we spec commissioning in most of our stuff. A lot of times we've got incentive grants, things like that require an M&V and commissioning program. It does get tendered. Sometimes it goes to the low bidder that maybe isn't the best person because it's at the end of the job. A lot of time, those aren't the first things that are awarded. And when we're already over budget, it doesn't necessarily get awarded to my top roster pick. Having said that, I will go back and look at them. Similarly to the project you were talking about, I've got that $65 million hotel retrofit. I'm recommissioning it this year because I know it was 3 years of construction. Yeah, it was commissioned in bits and pieces. Things got up and running, but no one's looked at it holistically as what it is now. That's a project for this year. And I'm doing it under operational cost because I'm positive I will save. We have a $6 million utility spend there. I'm going to save more than the $175,000 that these guys want to recommission this place. Those are things that do have definite paybacks. On that particular building, it was a no-brainer. I just gave them the go-ahead in January. I'm like, save it by mid-year. Like, just go start doing things and implement them. Come to me when you've got an idea. Don't write me a big report in June. Like, let's get these things flying. So, big proponent of commissioning, and I think taking a practical approach to it as well, and having these sort of ongoing relationships in commissioning. Scheduling, there'll be opportunities for savings as well. Like it's equipment running properly. There will be projects that come with it 100%. I've got bad delta T on certain loops, so I've got valves passing somewhere. Again, I've got 1,300 rooms that have 2 Belimo actuators per room. Some of them might be passing. But we're ordering a lot of new ones and going in and swapping those out. To be fair, I've got 95-year-old piping and some of that, so there's a lot of garbage in there. You can plug up valves pretty quick. Finding that stuff. There will be a ton of stuff that is found and that will become other projects. We talk about when we're going into this project, pressurization issues, having those conversations with operators. There was a lot of that stuff. I had conference centers for 5,000 people running 24/7 because otherwise the doors didn't open on the main lobby. I've got VFDs on all those fans now. I think we can balance the place a little bit better. Pretty much. Anybody goes in there, and these are guys I've worked with for years, and I just all sorts, and I'm like, all right, Jason, you're going in there, and you're going to find this stuff, and you come to me, and I'll figure out how to get the money to fix the things you find as you find them. So,
right.
Yeah.
I got to cut us off. We're 3 minutes past. These guys probably stick around for a few minutes, but I just want to give a round of applause to these guys. Thank you very much. If you want to hear more about commissioning, we do have a whole session on it tomorrow. Stephanie and I are doing a session on commissioning, and we have one more session in this room today by the great Phil Zito of the Smart Buildings Academy on what's the topic? Yeah, how to build out some schedules for smart building upgrades. Always informative, always a great speaker. So thank you, everyone.